In this video, we're going to be working on proving an identity. If you're not familiar with proving an identity, then this is definitely the tutorial for you. Hi guys, Lever here from Bright Young Brains. As mentioned, this is what we're working on in this tutorial. So in a situation like this one, we know that if we're going to prove that the left hand side is equal to the right hand side, we basically need to usually work with the side that is more complicated and then break that down until it looks like what we have on the other side. In our case here, we know that we are working with a lot of tan here. There's 10y here, 10y there, and then here we have 1 minus cos squared y. So in terms of us breaking this down, you may usually not want to mix brackets too much until you at least maybe have them as simple as possible. So in our case here, we already know that usually if you're working with a tan, you may want to change that to sine over cos. Now you may also be asking yourself, when do you change and where do you leave it? So in our case here, we know that we are seeing that there's a cos squared y here somewhere, and then here we're working with stuff that is tan in there. So clearly for these two to somewhat, gel, these we may want to convert into sine over cos, and then this here, anytime you have 1 over tan with the angle, this will always be cos over sine. So this is just sine y over cos y plus cos y over sine y. Now, you don't want to put yourself in a situation where you start cancelling things here. You can't, because these are being added together. What we can do here, though, is get an LCD or an LCM. In our case, getting a lowest common denominator here, we know that it is just cos y sine y. So we know that here we would need to multiply by sine y at the top and sine y at the bottom. Here we would need to multiply by cos y at the top and cos y at the bottom. This, if we get our LCD, we end up with sine squared y plus cos squared y over sine y cos y. And all we did was we got an LCD for these two. So what we now have is our expression on our left hand side. We may be thinking to ourselves, it doesn't seem to be getting any simpler. However, here at the top here, we know that this is just a square identity. And this is just a 1, because sine squared a value plus cos squared that exact same value, that will always just give you a 1. Now, at this point, you are a few steps closer to the final answer, or to you showing that the left-hand side is equal to the right-hand side. The reason is we know that this should also remind you of your square identity, because we know that 1 minus cos squared y, we know that this is just sine squared y. So this value here, we know that we're multiplying it by that value, and we know that this is technically over 1. This here, we know it is just a normal fraction. So we know that here, what we are going to end up with is that. And we can clearly see that the top multiplied by the top, the bottom multiplied by the bottom, we will end up with a scenario where 1 sine at the top cancels 1 sine at the bottom. The reason we can do that is because we are multiplying. We were not able to cancel stuff up here because we're adding. Here we can because we are multiplying. So 1 sine at the top will cancel 1 sine at the bottom there. And that's obviously going to leave you with sine y over cos y. And we basically do know that sine y over cos y is equal to tan y. So here, we know that you will be done, because we know that sine y over cos y is equal to tan y, which is basically equal to the right hand side. So in terms of you proving your identity, this will be good enough.